Hello class. Today we are looking at section 9.3, rational exponents. Turn to page 666 and let's look at some vocabulary. The first vocabulary talks about the rules of exponents, and we have talked about this at the very beginning of class. So the first rule is, we remember that we have x to the nth times x to the n. When you multiply, we know we have to add the exponents. When you divide, I have x to the nth over x to the n. When you divide, you subtract the exponents. When you have a power raised to a power, you multiply the powers. So we have x to the m times n. A base raised to a zero power equals 1. If we have a base with a negative exponent, you just write it on the opposite side of the fraction bar, and that makes it positive. And when everything, the entire base, is raised to a negative exponent, you write the reciprocal of the base. And when you write the reciprocal of the base, the outside exponent becomes positive. So we have reviewed this back in chapter 4. We talked about the different properties of exponents. So just make sure you review over those notes, because we're going to use this in chapter 9. On the next page, it talks about the rational exponents. And we will do examples of rational exponents today. On page 668, it has a summary of the definition of x to the 1 over n. You have the changing from rational exponents to radicals. And we know we hear the word radicals, we thinking about the square root, the cube root, the fourth root, fifth root. On page 669, you have the definition of x to the negative m over n. All of these vocabulary terms we will cover in our notes today. So as we do the notes, go back and reread those terms so you can understand what they mean. On page 671, it says using rational exponents to simplify radicals. So go to page 673 and let's look at number 29. Number 29 says change each expression into radical notation. So we know an expression is a problem without an equal sign. We know equations, we see equal signs. So we're just going to simplify this. We're going to change it. We're going to do a conversion. We want to change it to a radical notation. So let's look at number 29. I have 5 to the 104. And right here, my index is going to be your denominator, which is 4. My 5 goes under the radical. And then my exponent is that understood 1. So my answer is the fourth root of 5. And I don't have to write that 1. So right here, the 4 represents the index. And your index goes here. And your numerator, your 1, represents the exponent. We know exponent goes by that 5. Look at number 37. So for number 37, I have 6a squared b to the 1/4 power. We're doing the same directions. So right here, my index is the fourth root. And then I will write 6a squared b. And it's all understood to be to the 1 power, so I don't need to write that 1 again. And that is my answer. And we're changing a base with a fractional exponent to a radical notation. So a radical notation, we're going to see this symbol here somewhere in that notation. And the only thing may be different is your index. Go to the next section. It says simplify each expression if possible. So for number 41, we're going to take our new information and actually break down this problem as much as possible. So on number 41, I have 49 raised to the 1/2 power. So we're going to do a rewrite, and we're going to write it as a radical notation. So I have the square root of 49. So remember that it's an understood 2 here. It's an understood 1 there. So if you need to see it, just write it right quick. So we see the 1/2. And then go back and just clean it up without seeing the 2 and the 1. And we know the square root of 49 is just 7. Number 45, I have 1/9 raised to the 1/2 power. I want to rewrite this as the square root of 1/9. And we're going to take the square root of the numerator and denominator. So the square root of 1 is 1, and the square root of 9 is 3. And that is my answer. Again, all of these things you can type into your calculator as well. So it's very easy to put in the calculator. So let's practice that right quick. Do our calculator practice. So going back to number 45. On my Texas Instrument 84 plus E, I'm going to type in, I'm going to say parentheses, and then I have a button that says alpha y equal. So I'm going to say alpha y equal, enter. And on your calculators, I recommend it, you do have a fraction feature on your calculator. So you'll see 2 boxes. You'll see a box in the top and a box in your denominator. So you find your box on your calculator and you can type it in as well. Then I'm going to type in 1, move my cursor down, 9, move my cursor to the right, and then close parentheses. And then we talked about that little raise button on our last note. You have your little raise button here. I'm going to raise it. And then it says to the 1/2 power. So right here, I'm going to say alpha y equal again and enter. And I want to see another fraction. So I'm going to say 1/2. And when I hit enter, I get 1/3. Okay. So you see I get 1/3 for my answer. So that's a way you can also type it on your calculator to get that 1/3 also. Look at number 47. So 47, I have 1/8 to the 1/3 power. And I want to rewrite this as a radical notation. So I have the cube root this time of 1/8. And it's understood to be to the 1 power. So I don't have to write that 1 there. It's understood to be to the 1. Now, right here, I need to find the same number I can multiply 3 times to get 1. And the same number I can multiply 3 times to get 8. If I break this down, now we know that index of 3 means I need 3 of the same for it to come out of that root. So if I say 1 to the 3rd, I know 1 times 1 times 1 is still 1. And if I say 2 to the 3rd, I know 2 times 2 is 4, and 4 times 2 equals 8. So it's just we basically canceling everything out. And I'm left with 1/2. Number 51. It has negative 25 to the 1/2 power. So if I rewrite this, I have the square root of negative 25. Now, we talked about a square root of a negative radicand. If my radicand is a negative and we're dealing with a square root, fourth root, sixth root, we have to think of one number I can multiply twice to get negative 25. And it's not possible because 5 times 5 is positive 25 and negative 5 times negative 5. Negative 5 times negative 5 is also positive 25. It's not negative 25. So I cannot find one number multiplied twice to get negative 25. So right here, this is not real. But again, I want you to remember that if we did a cube root, it's possible because you can have, because 3 negatives still make a negative, or 5 negatives still make a negative. So if it's a odd root, I can take the third root, the cube root or fifth root of a negative number. But if it's a square root, a fourth root, a sixth root, I can't take the root of those, so it'll be not real. So odds are good, evens are not. Number 55. 55 says change each radical to an exponential expression. So we see an exponential expression, I'm going to see an exponent. I have the fourth root of 3a. So I'm going to write down my 3a as my base. I see 3 and a only one time. And I have an index of 4. And that is my answer. And this is very careful, very, very careful, because what part is connected to that 1 over 4? The 3a or just the a? Well, we talked about this back in chapter 4. I must put in parentheses. That way it lets me know that 3a is raised to the 1/4, not just the a. So parentheses you must write or it will not be correct. And we'll see that difference on number 57. So 57, I have 5 times the 7th root of b. Now this is a case where we don't do parentheses because 5 is not under the 7th root. So we just write the 5 down. We write the b down. I see b only one time and it's over 7, which is my index. And right here, you do not put this in parentheses because 5 was not under the 7th root. So you just bring your 5 over, and b is only understood to be raised to that 1 over 7. Whereas on 55, 3a, the entire part was understood to be raised to the 1/4 power. So very important that you put those parentheses in the right places. Number 63. It has a cube root of x squared plus y squared. So be very careful here because it is added together. You cannot separate these parts. They're like one big family. You have to keep them together. We have x squared plus y squared, and it's not raised to any power. So it's just one. I only see x squared plus y squared one time, and then my index is 3. And you'll know what I mean when I say only one time, because we're going to look at some problems where they have some other things written in there, and we'll know it's written more than one time. And we'll see that in just a minute. Number 65. 65 says simplify each expression, assume that all variables can be any real number, and use absolute value symbols if necessary. So we know that we start seeing those absolute value symbols when we're dealing with those square roots, fourth roots, sixth roots, because we want to make sure that whatever we plug in for x is going to come out positive. We have 25 y squared raised to the 1/2 power. I want to rewrite this as a radical notation. So I have these square roots. I'm going to break down 25. I know 5 times 5 is 25, and y times y is y squared. Okay, so again, when you're dealing with these types of problems, you're dealing with radicals, you can do so much. There's so many ways you can work these problems out and get the right answer. So just whatever way you're comfortable with, use it. We know this is understood to be a square root. If I do not see a number, it is a understood 2 in the index. So I need two of the same. I see a pair of 5s and I see a pair of y's. So my answer is 5y. But we want to remember that whatever y is, we want that answer to come out positive. So we're going to put those absolute value bars around that y. And that makes sure we don't come across any answers that's going to be not real. Number 73. Simplify each expression if possible. So for number 73, I have 25 to the 3 over 2. Now this is where we're going to see our radicand has more than one part. So we're going to see that in a minute. I want to rewrite this, and I have the square root of 25 to the third power. So what does that mean? That means I'm going to see 25 3 times. 1, 2, 3. Because it's to the third power. So I'm going to see 25 3 times. And that's what I meant earlier in our previous notes on how you'll see it only one time. But right here, it has an exponent of 3. So that means I write 25 out 3 times. But I need to remember that in my index, it is a understood 2 there. That means I need 2 of the same to make a pair. But this right here, I can do it so many ways again. The square root of 25 is 5. The square root of 25 is 5. And the square root of 25 again is 5. I'm done. So multiply together. 5 times 5 is 25. 25 times 5 is 125. And that is my answer for number 73. Look at number 81. Write each expression without negative exponents. Assume that all variables represent positive numbers. So again, we want to get rid of that negative exponent. You just move it across the fraction bar, and that's how you make it come from negative to positive. We have 4 to the negative 1/2 power. Now, I don't want to write it in radical notation yet. I want to get rid of that negative sign and then write it in radical notation. So I'm going to write 1 over, my base is 4, and my exponent is now positive 1/2. So again, I moved it across that fraction bar so that exponent can become positive. Now from there, I want to write it in radical notation, which is 1 over the square root of 4 to the 1 power. So remember, your 2 is in the index and your exponent is understood to be 1. Clean it up from there. So my answer is 1, and the square root of 4 is 2. And that's my answer for number 81. Number 87. I have negative 27 y to the third raised to the negative 2 over 3. Again, let's get rid of that negative exponent first, and then we will rewrite it in radical notation. So I want to get rid of that negative 2 over 3 first. To do that, notice that the entire base is raised to the negative 2 over 3. So when I rewrite it, I'm going to move everything to the denominator. Do not change that negative 27. The only thing that is changing is that negative 2/3 to positive 2/3. So be very careful not to change that coefficient into a positive. You only changing this sign here. Let's rewrite this in radical notation. I have the cube root this time of negative 27 y to the third squared. So this one's going to take a few steps. So just pay very close attention to what I'm doing step by step. And I'm going to move up my board as I'm doing it, so make sure you write everything down. Okay, before I move forward, let's review over what I just did. So right here, my goal is to get rid of that negative exponent. So to get rid of negative exponent, I have to move it to my denominator, or I'm just moving it across the fraction bar. The only thing that changes is that negative 2/3. It becomes positive. But make sure you do not touch that coefficient. Keep it like it is. Now, I have made my exponent positive, so I want to rewrite it as a radical notation. So when I say radical notation, I'm going to see some type of rule. We know that the index is 3 and my exponent is 2. Okay, so now this means that I write all of this down, the negative 27y to the third, twice. So again, there's so many ways you can do these problems. So just do the way you're comfortable with and just stick with it. Okay, so let's keep moving. I'll move my board up and let's keep going. I have 1 over the cube root I'm going to make this pretty long. I have negative 27 y to the third, and then I'm going to write it twice. Negative 27 y to the third again. Okay, so hopefully everybody understands that part. Okay, that's pretty easy, because it says that it is squared, so I wrote it twice. Now right here, I need 3 of the same. We talked about negative 27 in our previous sections. We know that the cube root of negative 27 is negative 3, because negative 3 times negative 3 is 9. 9 times negative 3 is negative 27. So the cube root of negative 27 is negative 3. The cube root of y to the third, so again, those 3's go away, and I'm left with y. You're going to do that same process again on the second one. The cube root of negative 27 is negative 3. And the cube root of y to the third is just y again. So instead of writing all those steps out, just think about it. Okay, just apply those mental math skills and just think about it. You also have a calculator. You can type in the cube roots. Okay, you can type in the cube root of negative 27, and I get negative 3 for my answer. And that's another way you can do it very quickly. So my answer is 1 over negative 3 times negative 3 is positive 9. Count the y's, because when you multiply, you add the exponents. Y to the second power. So my answer is 1 over 9y squared. Go to the next section and let's look at number 93. It says perform the operations. Write answers without negative exponents. Assume that all variables represent positive numbers. So for number 93, we want to definitely apply those property exponent rules. I have 5 to the 4 over 9 times 5 to the 4 over 9. Again, when I don't see a sign in between it, we know that's multiply. My base is 5. When I multiply, I add the exponent. So 4 plus 4 is 8 over 9. And that is my answer. Number 95. I have 4 to the 105 raised to the third power. Now again, we know that when a power is raised to a power raised to another power, we multiply the powers. That 3 is understood to be in the numerator. If you need to, put it over 1. That way you can see how to multiply it. Multiply straight across. I have my base 4. 1 times 3 is 3. 5 times 1 is 5. So my answer is 4 to the 3/5 power. Number 97. 6 to the negative 2/3 times 6 to the negative 4/3. Now, before I make my exponents positive, I am going to combine them because they have the same base, so I can add and subtract those exponents. My base is 6. Negative 2 plus negative 4 is negative 6 over 3. And you have to still remember your basic rules of adding and subtracting fractions. You must have a common denominator. So we know, and then you need to know your integer rules. When the signs are the same, add the number, keep the sign. So 2 and 4 is 6, keep the sign -6. And then your denominators are both 3, so that's your common denominator. Do simplify. So I have 6 to the negative 2. 6 divided by 3 give me -2. Then let's rewrite it. And we have 1 over 6 squared. And then you can clean that up one more time. And my answer is going to be 1. 6 times 6 is 36. So my answer is 1 over 36. So one more time. My bases are the same. So I can add my exponents. -2 minus 4 is -6 over my common denominator, which is 3. -6 divided by 3 is -2. I rewrite my base and exponent so that my exponent can be positive. So I move it across the fraction bar. My 1 is 6 squared. 6 times 6 is 36. And remember too that if nothing is left over in my numerator, we put a 1 there. Number 103. I have 2 to the 5 over 6 times 2 to the 1/3 over 2 to the 1/2. Now, right here, if you notice, I do not have any common denominators. So that's going to be a little issue because I have to find a common denominator to actually work these problems out. You also have a calculator again. You can type all of this in. You'll say 2 to the 5 6 times 2 to the 1/3. And then divide all of that by 2 to the 1/2. And use that little fraction button with the 2 boxes. Use that feature. And if you type that in, they'll give you your answer. And you should be fine. But if we work it out by hand, we must have a common denominator. So we have to remember those rules. I know that when I multiply, I add the exponents. But again, I must find a common denominator first. So my base is 2. I have 5 over 6. I want to go from 3 to 6. So my LCD is 6. So to make this a 6, how do I make 3 a 6? I multiply by 2. So if I multiply 3 by 2, I got to multiply that 1 by 2. So it'll be 2 over 6. Okay, so you got to remember those rules. I want 3 to be 6. So 3 times 2 is 6. And then if I multiply by 2 in my denominator, I got to take that 1 and also multiply by 2. So 2 times 1 is 2. So now I have my common denominator in my numerator. I'm going to go ahead and do my common denominator in my denominator piece also. So I have 2. Well, right here, I need 2 to also say 6. So I need to look at the common denominators for 6, 3, and 2. And it's going to be usually the largest number, or I have to find something bigger than 6, 3, and 2. But because 2 can go into 6, 3 can go into 6, and 6 can go into 6. That's my least common denominator. So I want to take that 2 and figure out how can 2 look like 6. If I say 2 times 3, I get 6 in my denominator. If I multiply by 3, I got to multiply by 3 to this 1. So 1 times 3 is 3. And 2 times 3 is 6. And just check your math and make sure it makes sense. Because 2 over 6 simplifies to 1/3. And 3 over 6 simplifies to 1/2 again. So I know I did it right. Okay, so all my denominators are the same. So now I start combining my terms. Again, if I'm going across, I'm adding. But if I'm going up and down, I'm subtracting. So we're going to keep that in mind as well. So I have 2. 5 plus 2 is 7 over 6. Divided by 2 to the 3 over 6. Do not simplify because you want your denominators to stay the same. So don't move too fast and start simplifying again. Now we know that when we divide, we subtract the exponents. So I have my base is 2. 7 minus 3 is 4 over 6. And then from there, my base is 2. I can simplify. Now I can simplify. Come down to one part. 2 going to 2. 2 goes into 4 2 times. And 2 goes into 6 3 times. So my answer is 2 and 3. 2 and 2/3. So let's go over all of that one more time. And then we're going to keep moving. So right here, my base is all the same, so I can combine all 3 of these terms. But the only problem is they must have the same denominator. My common denominator was 6, so I rewrote it. My 1/3 became 2 over 6, and my 1/2 became 3 over 6. After that, I know that when I multiply, I must add the exponents. So 5 plus 2 is 7 over 6, and it's still over 3 over 6. When I divide, I know I subtract the exponents. So 7 minus 3 is 4, and my common denominator is still over 6. And then from there, I simplify 4 over 6 to get 2/3. Okay, so let's look at 111 very, very fast. I'm going to go fast on this one. So I have x to the 3/5 times x to the 7/5 minus x to the 2/5 plus 1. But I'm going to rewrite 1. We know a base raised to a 0 power equals 1. So instead of me writing 1, I'm going to say x to the 0. So instead of writing 1, I wrote x to the 0 because we know a base raised to a 0 power equals 1. And from there, you can do your math and figure out your answer. So very, very important that you look at this one. So work out 111 on your own. And you should get x to the 2nd minus x plus x to the 3/5. Okay, any questions or concerns? Please let me know.